So in the previous video, we talked about the two categories of self-supervised learning, self-prediction and contrastive learning. In this video, we will learn more about a contrastive learning technique called SimCLR. So SimCLR stands for a simple framework for contrastive learning of visual representations. So how does SimCLR work? So first we take input images and we augment these input images. And the augmented images are then passed to the model. The model will then produce a general embedding vector, which is then followed by additional transformations, which then produce another output vector. So since we are still talking about contrastive learning here, we are still interested in minimizing the distance between two similar inputs. So in this case, if we have two augmented versions of the same input images, we can consider them as similar images. So similar to what we discussed in the previous video, we pass these augmented images to the model, which then produce these embedding vectors. And then if we have these output embedding vectors, our goal is for similar images to maximize the agreement. That means to minimize the distance. So as I mentioned earlier, we have these intermediate embedding vectors, which are followed by a series of transformations to obtain the final output embeddings. We can think of these intermediate embeddings as a more general representation of the input image. So here the network learns to extract general features. And the output embeddings are a little bit more specific to the specific training task here, minimizing the loss or the distance between two similar images. So for example, if we were interested in transfer learning following the self-supervised pre-training, we would actually maybe consider the more general representations in the intermediate layers if we want to add output layers for classification later on. So as I mentioned earlier, we want to minimize the distance between two similar images. So minimizing the distance is the same as maximizing the similarity. And here's an outline of the similarity function that we use in SimCLR. So S subscript ij stands for the similarity between input image I and input image j. So in the numerator here we have the dot product between zi and zj. Zi is the embedding vector of input image I, and zj is the embedding vector of input image j. So the denominator consists of this tau term, which is the so-called temperature factor. It's basically a value to scale the denominator. And then here we have the vector length of the embedding of input image I, and similarly we have the vector length of the input embedding of image j. So together, if you look at this term that I highlighted here, this may be familiar to you. It's actually the cosine similarity if you're familiar with linear algebra. And the cosine similarity is essentially an angle between two vectors. It's the dot product divided by the lengths of the vectors. So in other words, the similarity metric that we use in SimCLR is the temperature scaled cosine similarity. Alright, so now that we discussed the general concept behind SimCLR, what are the specific types of data augmentations that are used? And in practice, which data augmentation we use is yet another hyperparameter. So this includes resizing, cropping, changing the colors, changing the hue, rotating the image, or cutting out different parts of the image. But one aspect that the researchers highlighted in a SimCLR paper is that we shouldn't use more than two data augmentations at the same time, because this may be too much and then would degrade the performance of the pre-training using contrastive learning. So if we add more augmentations, actually the performance declines. So now that we discussed how we can use SimCLR for pre-training our neural networks, how do we actually use these pre-trained neural networks? So option one is adding an output layer to our neural network and then just training the network on the image classification dataset in the regular fashion. So the difference between self-supervised learning and regular supervised learning is that we have the self-supervised learning task where we obtain this pre-trained model, for example using SimCLR, and then we take this pre-trained model instead of a randomly initialized model and train it on our target dataset. So if you recall from the transfer learning lecture, another way we can use our pre-trained model is by only training the output layer. So we attach this new output layer and only train that layer while keeping the rest of the network frozen. Or option 3 would be not training the network at all, having it just create these output embedding vectors and then passing these output embedding vectors to a new classifier. So this classifier could be a neural network or a classic machine learning model that takes these embedding vectors as input and then learns the classification task. Alright, so in this video we covered how SimCLR works and how we can use a pre-trained model after self-supervised learning. In the next video we will be implementing SimCLR to make some of these concepts more concrete.